Okay, Assalamu alaikum everyone. Today we are going to start a new paper, and that is 2021 May June, and the paper is 2-3. बाकी जो आपके पास पेपर्स की रिकॉर्डिंग्स हैं वो आपके पास यूट्यूब चैनल पे अवेलेबल हैं, तो आप उधर से देख सकते हैं. Okay, let's start with question number 1. The elements in group 17 are known as halogens, and if you recall or if you look at the periodic table, you will find that group 17 have a first element fluorine, then chlorine, bromine, iodine, and astatine. Between the molecules of group 17 elements, van der Waals forces exist. Okay, so this is the important thing, that all of these elements exist as a diatomic molecules like this. And between these molecules, we have these van der Waals forces of attraction. State the trend in relative strength of van der Waals forces down the group 17. So if you look at their, uh, state, so at room temperature, fluorine is gas, chlorine is gas, iodine is liquid, sorry, bromine is liquid, iodine is solid, and astatine is solid. So it means that the molecules are getting closer to each other. And if the molecules are getting closer to each other, which means that the strength of van der Waals forces are increasing. So we just write that the relative strength of van der Waals forces increases down group 17. Is this understandable to everyone? Now, in the next part, state physical state of each of the halogens under room conditions. So here I have already mentioned these states. So if we look at chlorine, it is gas at room temperature, bromine is liquid at room temperature, and iodine is solid at room temperature. Is this understandable? Okay, now next part. A solution of aqueous bromide ions is added to a separate sample of chlorine and iodine. So they are saying that once bromine, sorry, in a one experiment, aqueous bromide is added to chlorine, and in another separate experiment, aqueous bromide is added to iodine. Describe what is observed in each reaction. Okay, explain your answer in terms of relative reactivity of these elements as oxidizing agent. So if you look at the positions, let me write over here again, group 17 elements as they are in their group in the periodic table. So at topmost is fluorine, then chlorine, then bromine, then iodine, and then astatine. What we know, when we move down group 17, the reactivity decreases, which means that the element is which is on the top is more reactive than the element which is beneath it. So when we add chlorine to the solution containing aqueous bromide ion, the reaction would take place forming chloride. As there are two chlorines, so two chloride ions are formed, and bromine. Okay, so to balance this equation, I have to put 2 over here. But when iodine is passed in a solution containing bromide ions, as iodine is below, you know, bromine, so here there is no reaction as iodine is below. So when we talk about observation with chlorine, as in the reaction of a chlorine with bromide ion, we are observing that bromine is forming. And if this bromine is forming, then the solution becomes brown, or you may write orange. But here, when it's a bromide ion, the solution is colorless. So here I would write the observation that it goes from colorless to brown. And in iodine, I may write there is no visible change, as we have already seen that the reaction could not occur. So there is no visible change. Is this understandable to everyone? Now,
सर
explanation.
ये आयोडीन वाला समझा दूं रिएक्शन जो भी है
Okay, the Abdurrafe, the trend is that the reactivity decreases down the group, which means I can say it is most reactive element and it is least reactive, right? So the rule states that what the rule states that the one which is more reactive element displaces the ion of the less reactive. That is the rule, or that is the trend, that how the reaction takes place. I am writing over here the rule that more reactive halogen displaces the halide ion of less reactive halogen. So if we observe over here, in this case, we have a iodine and bromide. So when I compare these two, can I say that this halide is of more reactive halogen? Are you getting this point, Abdurrafe?
यस
And this is less reactive halogen. So that's why there is no reaction occur. And if there is no reaction, so you are not going to observe any visible change over there. Now, is this understandable?
यस सर
Okay, but when we compare this over here, when we are using chlorine along with bromide, so chlorine is above bromine in the periodic table, which means I can say that the halogen is more reactive and the halide is of less reactive. Okay, halogen. So that's why reaction would occur. So here reaction occur, and here reaction would not occur. Now, is this clear? Okay. So the answers are the one which were written in the blue. The rest of the things are for your explanation. Okay. So what I will do the explanation. Okay, look over here. When it's a chlorine, it gains electron when it reacts forming chloride, and gain of electron means in the same way when iodine reacts, iodine also gain electron and become iodide. So gain of electron is called reduction, and the one which undergo reduction are basically oxidizing agent. So as we are saying, observing that chlorine reacts with bromide ion, and iodine would not react with bromide ion, and iodine is below and chlorine is above. So I can say that if chlorine is can react with bromide ion, so I can say that chlorine is stronger oxidizing agent, but iodine is weaker oxidizing agent than bromine. Yes, is this part is clear to everyone? Yes, if anyone have any confusion, kindly ask. And remember, the writings which are in the blue are the answers that you have to write during the paper. Now, next, bleach is made by chlorine with cold NaOH. Write an equation for a chlorine with cold NaOH. So this equation you need to memorize that when chlorine reacts with cold NaOH, we will get one NaCl. We will get one NaClO and H2O. If you try to balance the equation, you have to put 2 over here. Now your equation is balanced. And this NaClO is the compound which act as bleach. Is this clear? Yes, if anyone have any query, kindly ask. Okay, then let's proceed further. When ClO negative aqueous is added to water, it behaves as a Bronsted-Lowry base. So whenever we talk about Bronsted-Lowry base, we can say which accepts H positive ions. Define the term Bronsted-Lowry base. So we have to state only this, that we can call proton as well to H positive. So H positive, or you can write proton. Acceptor is defined as a Bronsted-Lowry base. Is this clear? Next part, write an ionic equation for the reaction between ClO negative and H2O. And they have told us earlier that ClO negative, when reacts with water, it is behaving as a Bronsted-Lowry base. So during this reaction, I have to show its behavior as a base. And if ClO negative is behaving as a base, then it means H2O must behave as an acid. So acid is the one which donates H positive ion, which is H positive ion donor, and base is the one which accepts H positive ion. Okay. So if I'll write the equation, I will write ClO negative plus H2O. So when it acid behaves as an H2H, when water behaves as an H acid, it releases the H positive ion. So the remaining species is OH negative ion. Okay. Now the the H positive ion that is actually released by water is gained by HClO negative. So when HClO negative bonds with positive, we will get HClO with a no charge on it. So that is how we will write the equation. If anyone have any problem in understanding this equation, kindly tell me. Yes, is this clear to everyone? Okay. Now, the concentration of NaClO in bleach S is x gram per dm cube. Okay. NClO reacts with H2O2 as shown. We have an equation. Now 5 centimeter cube sample of S completely reacts with H2O2. The volume of oxygen produced is 24 centimeter cube under room temperature. Assume that only the NaClO in S reacts with H2O2. Okay, now you have to calculate the value of X. Okay. So X is the amount of NaClO in bleach S. So we are provided with volume of oxygen and we have to find, the mass of NaClO. If I'll find the mass of NaClO, then I can able to find the mass in decimeter cube as well. So if you look at the equation, there is a 1 mole of oxygen, and 1 mole of oxygen means 24,000 centimeter cube of gas is produced. So while making the ratio, the first information that I have took from the equation is telling me that 24,000 centimeter cube of oxygen is formed, and it is formed from 1 mole of NaClO, and 1 mole of NaClO have a mass equal to its AR. So if I'll find its AR, then it is 23. That is the AR, it's MR, sorry. So to find the MR of NaClO, we would add up the AR of the elements present. So first one is sodium 23, then chlorine 35.5, and then oxygen 16. So can anybody tell me the answer? 58.5, 68.5. Is it 74.5? Yes, can anybody confirm me? So from the equation, what I get to know that when 74.5 grams of NaClO reacts, the volume of oxygen produced is 24,000 centimeter cube. Is this understandable to everyone? Now, in the experiment, there is 24 centimeter cube of oxygen is produced. So the mass of NaClO used must be X. So first what I will do, I will find the mass of NaClO that would be equal to 24 times 74.5 divided by 24,000. So yes, can anybody tell me this mass of NaClO? Yes, please. Can anybody calculate the answer and tell me? Yes, can anyone tell me the answer?
grams.
Sorry, can you repeat, Shahan?
Sir, 0.0745.
0.0745 grams. And if you see over here that the volume we have used for SS7, 5 centimeter cube. So it means this is the mass of NaClO in 5 centimeter cube, right? And we have to find the mass in grams that must be in a 1 dm cube. So we know that 1 dm cube is equals to 1000 centimeter cube, right? So what I know that in 5 centimeter cube of S, we have 0.0745 grams. And if I have 1000 centimeter cube, then the mass of NaClO would be X. So if I'll find the X, it would be 1000 into 0.0745 divided by 5. And it would give me the mass in grams per dm cube. Yes, can anybody tell me the answer over here?
$14.9.
Okay, so it is 14.9 grams per dm cube. Yes, is this solution is clear to everyone? If anyone have any confusion, kindly ask. Yes, is this clear to everyone? Okay. Sodium chlorate 1 NaClO, as this chlorate, the one in the Roman written over here is informing us that chlorine have a +1 oxidation number over here. Oxidizes dilute hydrochloric acid to form 3 products. Okay. The products which contain chlorine have a chlorine species with oxidation number -1 or 0. Okay. No other species changes its oxidation number during the reaction. Okay. Use this information to complete an ionic equation. So we are getting two kinds of species having chlorine. Either it have a one have a -1 oxidation number and the other one have a 0 oxidation number. Okay. So if it have a -1 oxidation number, then it must be chloride ion. And if it have a 0 oxidation number, then it must have a Cl2. See, this -1 is telling me that there is chloride ion is formed, and this 0 over here is telling me that chlorine would form. Okay. Now, if you look at the reactant side, we are left with the hydrogen and oxygen. So it clearly indicates that the third product must be water. Now, if I have to balance the equation, as I got two water over here, two hydrogen over here, and here I have a one hydrogen only. So I would place 2 over here as a coefficient and 1 over here as a coefficient. Now my equation is balanced and correct. Yes, is this is clear to everyone? Okay. Now, this is question number 2. Methanol CH3OH is soluble in water because it forms hydrogen bond with water molecule. Okay. Draw a fully labeled diagram to show how a hydrogen bond forms between water molecule and methanol. You have to make sure three things while making this diagram. And for these three things, the first one is the structure. Second one is the dipole. And lone pair. And the third thing you need to show is dotted line, which actually represents hydrogen bond. So we have to make sure that what I have written in these 3 points, these must be shown correctly to get all the 3 marks. And another thing that you have to keep in mind over here is that hydrogen bond is the attraction between the hydrogen of one molecule and the fluorine or oxygen or nitrogen of another molecule. But there is another restriction over here or another condition over here, and that condition is the hydrogen must be covalently bonded to fluorine or oxygen or nitrogen. So this is the thing that you need to keep in your mind while drawing a diagram to show the hydrogen bond. Okay. So we have to show the hydrogen bond between methanol and water. So if I draw a displayed structure of methanol as it's CH3OH, so there are 3 hydrogens which are bonded to carbon and 1 hydrogen bonded to oxygen, right? So if I talk about these 3 hydrogens, cannot show hydrogen bond as they are covalently bonded to carbon. And if I talk about this hydrogen, so I can say that it can show hydrogen bond as it is covalently bonded to oxygen. Is this point is understandable? So when I'm going to show the hydrogen bond, I will write CH3OH. That is the structure. Now, as this hydrogen is bonded to a oxygen, so this hydrogen must be a positive charge and this oxygen must be a negative charge. So this is the one molecule. Then the other molecule must be water, which have oxygen bonded to 2 hydrogens. So this oxygen have a lone pair. And again, the hydrogen that are bonded to oxygen are partially positive and the oxygen is partially negative. So this oxygen of a water molecule can attract this partial positive hydrogen, and we show this attraction by these dotted lines, and this attraction is a hydrogen bond. Is this clear to everyone?
Yes, sir.
Or we can show this hydrogen bond the other way, as if I draw a water molecule over here, so this hydrogen have a partial positive charge and this oxygen have a partial negative charge. And here I have a other molecule which is of methanol. And in this methanol, this oxygen is partial negative and this hydrogen is partial positive. So this oxygen have a lone pair of electron. So this oxygen atom of a methanol molecule can attract the hydrogen that is partially positive of water. And we show this attraction by these dotted line. So these dotted line actually represents hydrogen bonding. So I have shown you the hydrogen bonding in 2 ways. The first one where the hydrogen bond is between the hydrogen of a methanol and the oxygen of a water. And in the second diagram, the hydrogen bond is between the hydrogen of a water and the oxygen of methanol. You can draw any one of the diagram and you will be marked 3. You will be get getting 3 marks because you have drawn the complete structure, you have drawn the dipoles, you have drawn the lone pair, and you have drawn the dotted line to represent the hydrogen bonding. Yes.
सर ये ऑक्सीजन के ऊपर जो CH3 बॉन्डेड है सर, इसके ऊपर भी पार्शियल पॉजिटिव चार्ज नहीं होगा?
Yes, it do have a partial positive charge, but it is not involved in hydrogen bonding, so there is no need to show the partial positive charge over here.
सर अगर है तो कैंसिल आउट नहीं होना चाहिए, मतलब पार्शियल नेगेटिव से पार्शियल पॉजिटिव कैंसिल आउट नहीं हो जाएगा?
Why would it cancel out?
सर उसकी वो बन रही है ना, इसकी जो बॉन्डिंग बन जाएगी सर 180 डिग्री एंगल पे बनेगी।
No, there is no 180 degree because oxygen have a lone pair, and due to this lone pair, the shape is bent.
सही है, ठीक है सर।
Okay. If anyone have any other question, kindly ask. Okay, then. Methanol has a melting point of 97.6 degrees Celsius and a boiling point of 64.7 degrees Celsius. Okay, minus 97.6. A sample of a pure liquid methanol is added to a flask and then sealed. The flask is left for several days at constant temperature. The vapor pressure is then measured as a 17 kilopascal, so it have a pressure. Okay. What is meant by the term vapor pressure of a methanol? This part is now out of syllabus, so I'm not going to discuss it. And if you would find anything regarding vapor pressure, so you may also leave. It is till 2021 only. Since 2022 onwards, the vapor pressure is not the part of the syllabus. Okay. Explain why some liquid becomes vapor. So it's the concept of evaporation that we all know that any liquid can evaporate at any temperature below its boiling point, right? So, and why would it happen? It happened to the molecules or the particles which are on the surface and they have enough energy to become a gas or to become a vapor. So we would write this only, that the liquid particles which are at the surface have enough energy to overcome the forces of attraction and become vapors. Now, next part. Suggest and explain why the vapor pressure of a water at room. Okay, see again, it is about vapor pressure. So it is now out of syllabus. Let's move to the part C. Methanol is made by reacting carbon monoxide with a hydrogen. The carbon monoxide and hydrogen react at 1 exponent 7 Pascal and 200 degrees Celsius temperature. So we got that pressure and temperature. Eventually, the reaction mixture reaches dynamic equilibrium. Okay. The amount shows of each species present in the mixture. Okay, we got the species amount of each species at equilibrium as well. See, they have given you the equilibrium amounts as well. Okay. Explain what is meant by the dynamic equilibrium. So we would write that it is the state when the rate of forward reaction becomes equal to the rate of backward reaction in a closed container. Okay. Now, what they are asking, calculate the partial pressure of methanol vapor at equilibrium under these conditions. Show your work working. Okay. So this is basically considered as the total pressure. And if we have to find the partial pressure of methanol, for partial pressure, we represent the partial pressure with the italic P. So the partial pressure of methanol would be equal to mole fraction of methanol times total pressure. And when I talk about the mole fraction of methanol, so the mole fraction of methanol must be equal to moles of methanol divided by total moles. So here you go. I have a moles of methanol, that is 0.97, divided by total moles, which would be 0.03 plus 0.06 plus 0.97. So can anybody solve me and tell me the answer? Yes. Yes, what is the answer? Yes, can anyone calculate it?
Sir, 33.7.
Beta, we are finding the mole fraction, and remember mole fraction is always, its value is lower than 1, so it means you did some mistake. Calculate it again.
Sir, 0.915.
0.92 answer.
0
0.92.
0.92. Two significant figures में आप जा रहे हैं, it would be wrong. Shahan,
0.915.
0.915.
0.915. Okay, so we got the mole fraction. Now, the partial pressure of methanol is equals to mole fraction, which is 0.915 times total pressure, that is 1 exponent 7, that is given over here. So 1.0 exponent 7. Yes, can anybody tell me this answer? Yes, what is the answer over here?
Sir, 9.15 exponent 6.
9.15 exponent 6. So 9.15 exponent 6 pascals. Okay. Now, what they are asking you to write an expression for the equilibrium constant Kp for this reaction, state the units in your answer. Okay. So here we got the equation. Let me rewrite the equation over here. That 1 mole of carbon monoxide gas is reacting with 2 moles of hydrogen gas in a reversible reaction, forming 1 mole of methanol as a gas. See, it's a gas over here. So in Kp expression, we always use the partial pressures of the gases and again the product over reactant. So I would write partial pressure of methanol divided by partial pressure of carbon monoxide multiply by partial pressure of hydrogen raised to the power 2 as it have a 2 moles. So if I have to find the units, the unit over here provided is a Pascal. So in numerator, I have a 1 pressure, so it would be Pascal divided by, who left the class? Okay, divided by partial pressure of carbon monoxide, which is also in Pascal, multiply by square of the partial pressure of hydrogen, so which would be Pascal square. So these two would get cancelled out and I would be left with Pascal inverse square. So I will write over here Pascal inverse square. Yes, is this part is clear to everyone? Yes, is this is clear?
Yes, sir.
Now, here this is question number 3. Separate samples of R, S, T, and U are added to cold water. The identity of each sample is unknown. However, each sample is known to be pure and can only be one of barium hydroxide, sodium chloride, phosphorus 5 oxide, and silicon 4 chloride. Use the observations in the table to identify each sample as one of barium hydroxide, sodium chloride, phosphorus 5 oxide, and as silicon chloride. Write your answer in the table. Okay. So I can easily figure out something and comment on these. barium hydroxide. Then I have a sodium chloride. Then I have a phosphorus oxide. Then I have a silicon chloride. Okay. So it's a metal hydroxide, which means it must be basic or alkaline. More specifically, it is an alkaline because barium is at the bottom of the group 2, and in group 2, if we move down, the solubility of hydroxide increases. So barium hydroxide is relatively more soluble, which makes it alkaline in nature. When we talk about sodium chloride, it's a neutral compound and it's a salt. P4O10, a non-metal oxide, and non-metal oxides are acidic in nature. Silicon chloride, when we talk about silicon chloride, it's also a non-metal chloride having a very small cation. And you may remember this, that the cations which have a very smaller size, their chlorides are acidic as well. So first one is a solid, alkaline, colorless solution is produced, some white solid remains. So as we have out of these four only one compound alkaline, which is barium hydroxide, so I would write the formula or the name of the barium hydroxide over here. Is this understandable? Now again I have a solid. White solid disappears, solution is neutral. So the neutral compound that we have is sodium chloride. So I would write its formula over here. Then misty fumes is produced, white solid is made in vigorous reaction. So let me tell you, it's silicon chloride, because when silicon chloride reacts with water, we got two things. One is SiO2, silicon dioxide, as it's a giant covalent, so it does not dissolve in water. So we would observe a white solid. And then after this white solid, we get HCl. So this HCl also form as a gaseous state as well. Alaikum assalam. 9, 15 minutes. रुको. Okay. So as it is insoluble, so we got a white solid, that is silicon oxide. HCl is formed in very large amounts, so it gets dissolved as well. But beside this, misty fumes are also observed. So I can conclude that the liquid T is SiCl4. And then acidic, colorless, produced in vigorous reaction. So acidic, we are left with only P4O10, phosphorus 5 oxide. So we would write P4O10 over here. Is this clear? Okay.
Yes.
Now, question number 3, part 2. 3A, part 2. Identify the formula of white solid made when sample T reacts with water. So see, I have already figured it out. So I would write its formula SiO2. Then name the solution formed when sample U reacted with water. Okay, so sample U, as we have discovered that it's P4O10 and acidic oxide. So whenever non-metal oxide, which are acidic, dissolves in water, forms acid. So here I would get H3PO4, which is phosphoric acid. And to balance the equation, I have to put 4 over here and 6 over here. So the solution of phosphoric acid would form. So I write phosphoric acid over here. B part, magnesium oxide, it's MgO, aluminium oxide, Al2O3, have a properties typical of a ceramic material. Name one physical property of a ceramic material that, okay. There is a one property that ceramic material have, that they have a very high melting point. The other property that ceramic material have, that you can write over here, that they are insulator or non-conductor of electricity. And there is another property that ceramic material have, they are very strong.
सर ब्रिटल नहीं होंगे?
No, they are not brittle. Actually, they can be brittle, but by applying very high force, they cannot be broken easily. Okay. When we talk
सर
about
लेकिन जब इलास्टिक नहीं तो ब्रिटल हो गया ना?
but brittle, okay, brittle, what does brittle means?
Which can break upon applying force and not get elastically deformed.
Which can break upon applying force, that those are brittle substances. But the thing is that when we talk about the ceramic material also brittle, but to break them we have to apply a very huge amount of force. They cannot be broken down by applying a smaller or a little amount of force, because the bonding in the ceramic material is actually very strong. For example, I would tell you that when we look at the melting point, I'm not talking about the boiling point, okay? When we look at the melting point, its melting point is around 2400 degrees Celsius and its melting point is around 2200 degrees Celsius. These are not the exact figures, I'm telling you the round figure. And there is one important thing that you need to know over here, that magnesium oxide is too strong that it is used to line the inner walls of the furnaces. Because they are stable to heat as well. They are thermally stable. They cannot be, broken down or decomposed by very easily if we provide the heat. Okay.
Okay, sir.
Next, give the formula of another period 3 oxide which behaves as a ceramic material. Yes. Okay. If you guys, let me tell you, we have a sodium in period 3. Then we have a magnesium in
सर
period
सिलिकॉन
3.
होगा ना, सिलिकॉन ऑक्साइड.
Yes, very good, Shahan. It's a silicon, then aluminium, then silicon. After silicon, we have phosphorus, sulfur. So it's a sodium oxide, magnesium oxide, aluminium oxide, silicon oxide, phosphorus oxide, sulfur dioxide. So it have a giant covalent structure and a very strong forces of attraction. So it can be a ceramic material as well. So it's silicon 4 oxide, SiO2. Is this clear? Okay. Next part. Tungsten oxide, WXOY. Okay, we don't know how many tungsten atoms are there and how many oxygen atoms are there. Used to give color to a ceramic materials. A sample of WXOY contains 79.29% tungsten by mass. Calculate the empirical formula of WXOY. Okay, so I know the mass of tungsten, that is 79.29. So first I have to find the mass of oxygen. So mass of oxygen in tungsten oxide would be 100 minus 79.29, which would be equivalent to, I think, 20.71, right? So you have to do it the same way as you do in O levels. 79.29 and 20.71 divided by the AR. AR of oxygen is 16, AR of tungsten, let me see, where is, I don't remember the AR of tungsten. Here it is. What it is, 183.8, right? So 183.8. Yes, can anybody tell me the answers? Yes, 79.29 divided by 183.8. Yes.
0.431.
0.431.
431.
And for oxygen, it would be 1 point something.
1.29.
29.
1.29. So the smaller value is 0.431. So we divide both the values with 0.431. So here I got 1. And I think here you got 3.
Yes, sir. 2.99.
2.99. Okay. So 2.99, which is round off to 3. So the formula would be WO3. WO3. Yes. Is this clear to everyone?
Yes.
Okay. So we have ended 3 questions till here. And now we are left with the 2 questions. And that is, I suppose, okay. Almost it is of organic, the 2 questions. And if you see, there is 12 marks from 1 question and 10 marks of 1 question. Okay, 22. Okay, so I'm keeping the class till here, and in the next class we will resume this paper. Okay. Okay, take care everyone.
Allah Hafiz.
Allah Hafiz.
Allah
Allah
Hafiz.
Hafiz.